Alright, next we want to look at part 4 of this question. Now this question, part 4 requires us to calculate the impedance of an AC circuit. Right, with the information given, the input voltage waveform and the current waveform, I can make use of Ohm's law to calculate the impedance Z, right, equals to Vt over It. But since we in part 3 we are asked to calculate the phasor version, so I can use phasor version as well to do the calculation, right? The phasor version of voltage over current, and that's what we calculated in the previous example, which is 14 angle minus 36 degree volt divided by the current, which is 3.536, the angle of 30 degrees ampere. That gives me about 4 angle minus 36 minus 30. That's 4 minus 66 degree ohms. Right? This is the phasor version of the impedance, but the question wants me to convert this to rectangular version. Right? So using your calculator, you should be able to get this value, 1.627 minus J, 3.654 ohm. And that's the answer for part 4, right? But then for part 5, it asked me to look at what are the components that forms this circuit. So looking at the impedance comprising of two parts, the real and the imaginary part. The real part will correspond to the resistance, right? So resistance is 1.627 ohm. The imaginary part, because of the minus J, so it tells me this is a capacitance reactance. So the capacitance reactance value is 3.654 ohm. Now, this is equals to 1 upon 2 pi Fc, right, where 1 upon 2 pi F is actually the omega. So we know from the waveform expression, omega is actually equals to the angular velocity. So angular velocity is given as 628 radians per second multiplied by the unknown value c. Right? Since I know xc, I can calculate the capacitance of this circuit, which is equals to 628 multiplied by 3.654. That gives me about 436 times 10 to the minus 6, that is microfarad. Please remember to put in the units. In other words, this circuit comprises of a resistor with the value 1.627 ohm and a capacitor with a value of 436 microfarad. So if I were to draw this circuit, it will be something like this. Alright, this is the resistor R, equals to 1.627 ohm, connected in series, because it's plus, right? So in series with a capacitor with a value of 436 microfarad. Right, the input voltage is Vt. The input current coming in is It. Alright, so that's the circuit required for part 5. Okay. We then go on to the part 6. Now, part 6 requires us to calculate the power factor. Right now, power factor is actually given by the cosine of the phase difference between the voltage and current. So in this case, it's the same as the phase shift of the voltage minus the phase shift of the current. This gives me a cosine of minus 66 degree. In terms of value, it is the same as cosine 66 degree. And that gives me 0.407. Now, in this case, the current is phase shift is a positive angle, whereas the voltage phase shift is a negative angle. In other words, the current, if you look at the phasor diagram earlier, the current is ahead of the voltage. So in this case, we will put that as leading, right? The power factor is 0.407 leading. Remember just now we draw the phasor diagram. The phasor diagram voltage is here. The current is ahead, right? And this angle is the 66 degree. Right, so that's the power factor. Next, we want to know the real power. Now, the real power P is given by the RMS voltage multiplied by the RMS current multiplied by the cosine of the phase difference angle. That's equals to 14.14 multiplied by 3.536 multiplied by 0.407. That gives us a power of 20.34 watts, right? Remember, power is in watts. Whereas the reactive power is given by the formula Vrms multiplied by Irms multiplied by the sine of this phase angle. So that will give us 14.14 multiplied by 3.536 multiplied by the sine of 66 degrees. So that gives us 45.68. Now instead of watts for reactive power, we use VAR, voltage ampere, R to tell people that this is a reactive power. Now, what's left for us to do is to draw the power diagram. Now, what is a power diagram? Now, power diagram basically is a relationship. In this case, the real power on the horizontal because it's resistive, right, which is given to P is 20.34 watts. The reactive power. Now, reactive power, because this is capacitive, we draw it downward. Q is to 45.68 VAR. Okay, so the apparent power is like the power available. This angle is 66 degrees negative. So this is the apparent power. Yes. Right, so this is what we call the power diagram. Alright, so that's for all the sub-question we need to do for part A, question 1.